I tape this on the wall, actually.
Okay. Lesson 2.1, part 1. Lesson 2.1 is linear and quadratic functions and modeling. Specifically, in part 1, we are worrying about the linear pieces. Okay? Now, I will say that homework listed up there is specifically the homework for part 1. Okay? I do have a separate set of problems that go with part 2, and that is on Schoology if you want to grab it sooner rather than later. Okay? Now, we're going to do some stuff that takes us back to pre-algebra, algebra. You've talked about polynomials before. Okay? Polynomials here, any function that is a sum or difference of x values having whole number powers and real number coefficients. So there's some key words in there. Sum or difference of x values, so that just means x terms added and subtracted together. They must have whole number powers and real number coefficients. Real number coefficients, we're not talking imaginary, okay? Whole number powers. What are whole numbers?
Positive.
Positive, right? So officially they do start at
1.
One. No, 0.
Zero's not a whole number.
They do start at 0.
What?
0, 1, 2, 3, 4, so on and so forth. The counting numbers are the ones that start at 1, or the natural numbers. Whole numbers do include 0. Okay, so just kind of remember that. So we're going to be, one thing we're going to look at is classifying, is it a polynomial, is it not a polynomial? Some special polynomial names, okay? I'm going to actually start at the bottom of this because I think these will be more familiar. If something is a cubic, what does that mean to you? If it's a cubic, its highest power is 3. Okay. That means if the highest powered term is a 3, the degree is 3. And your leading coefficient is the number in front of that highest powered term. So if x cubed is my highest powered term, the number in front of it, in this case just represented as an a, is our leading coefficient. Quadratics. A quadratic is an equation where the highest power is a 2. So ax squared plus bx plus c. That would be degree 2. Leading coefficient is always whatever in front of x squared. Linear. Linear function has the highest power of 1. So that's your mx plus b, or it's listed as ax plus b here. Degree 1, same leading coefficient. Constant function. A constant function is when there is no x. Okay, so for instance, f of x equals a, where a is not 0, a is some number. In this case, your x is an invisible x, so you could think x is 0. So it is a degree 0 if there's no x, if there's a number but no x. Leading coefficient a again. 0. 0 is a special, it gets its own special name. I mean, it could fall under the constant function, but it doesn't do that because it's just the number 0. And its degree is undefined. And its leading coefficient is just itself the 0. Okay? So, a little bit of information there. Let's go to look at example 1. 4 pieces here, and 3 questions on each of them. Which of the following are polynomials? For those that are, state the degree and leading coefficient. For those that are not, state why not. Okay, thoughts on A. Is it a polynomial?
Yeah, yes.
Okay, I'm hearing yes, it's a polynomial. In other words, it fits into the category of sum or difference of x values, whole number powers, real number coefficients, yes? Okay, you've got basic x terms added and subtracted, so yes, it's a polynomial. If it's a polynomial, state the degree, what's the degree?
3.
Okay, highest power of 3. If you wanted to name that, it would be called a cubic. Okay, and then what is our leading coefficient? 4, because it's a number in front of the x cubed term. Yes? Okay, questions on A? Okay, B. First questions first. Is it a polynomial? No? Why not?
Still -4.
Okay. So this one is not a polynomial. The big issue is the power. While it looks like a nice neat power, because it's not like a fraction or anything, it's a negative. And a negative power would take this x to the denominator. We're supposed to have x terms being added or subtracted, and x in the denominator does not work. That -4 is not a whole number because it's negative. So state why not. My explanation is going to be that the power is not a whole number. And that's because it's a negative. Okay? C, h of x is the square root of 9x to the 4th plus 16x squared. Is it a polynomial?
Yes.
Why?
Because if you square root it, it would be 3x squared plus 4x.
However, we can't take a square root of a sum. You can't take if those were multiplied together, we could talk about taking the square root. But because those are added together, we can't take that square root.
So no.
Square root. What kind of power is a square root?
Square.
What is the power? Like if I rewrite this instead of with a square root sign, it is to the power of, I don't know if I've heard it or not.
Negative.
No? Negative just takes its denominator.
2.
No, it's not 2 because that would be squared, not square root.
1/2.
1/2.
Oh.
That was definitely a shot in the dark, but it worked.
I still hit it.
Okay, so fractions, remember, are radicals. Does this ring a bell? Okay, it should. We did this last year in Algebra 2. Okay, so a square root is the 1/2 power. A cube root would be the 1/3 power. A fourth root would be the 1/4 power. Okay, obviously that part of Algebra 2 did not stick. Now, with this information, is this a polynomial?
Yes.
No.
Oh, just kidding.
Right
Yes.
next to the 4.
Number.
Okay, there would have to be a whole number power. And what is a square root? Not a whole number power, right? A square root, any type of root, is a fractional power. So I'm going to say no. And this time my explanation is power is not a whole number. Except this time, instead of putting negative, I'm going to put the fact that it was a fraction. Okay? Or you could talk about the fact that it is a square root. Okay? D. K of x equals 15 minus 2x to the 4th. Is it a polynomial?
Yes. Yeah, it is.
But the highest coefficient is half. Does that have to be written first?
Is it a linear function?
Nothing says it has to be written first.
Oh.
Because can I take terms that are added and subtracted and rearrange them how I want?
Yeah.
Yeah. So the order that the pieces are written in aren't going to matter. You can reorder them as you need to. So this is x values added and subtracted, whole number powers, real number coefficients. So yes, it is a polynomial. If it is a polynomial, one thing we need to study degree. What?
4.
Why 4? It's the highest power. Does it matter that it didn't come first? No. Okay, it doesn't matter that it's not first because we can take those terms and rearrange. If 4 is my degree, what does that make my lead coefficient? Okay, good. Lead coefficient is -2 because that is the number in front of my highest power. Got it?
Yeah.
Okay, that's stuff you've done in algebra and pre-algebra. It's just been a moment, right?
Yeah.
Okay, moving along. Let's talk about linear functions. So, a linear function specifically, a polynomial of degree 1 with a leading coefficient equal to the slope. So degree 1 just means highest power is x to the first. Leading coefficient equal to the slope, well, in the form they like to state, it's f of x equals ax plus b. What do we usually think of that as? That's y equals mx plus b, isn't it? Okay, so swap their idea of a out for our idea of m, and that's the idea. Now, a couple comments here. Horizontal lines are graphs of constant functions. Remember the constant up above? The constant function was f of x equals a. So that's the same thing as saying like y equals a number. And so if it's y equals 4, that is the horizontal line that goes through the y-axis at 4, right? Okay, so horizontal lines are graphs of constant functions. Vertical lines are not functions because vertical lines will not pass the vertical line test. Remember, in order to be a function, something has to pass the vertical line test. We talked about that in the last unit, right? And they would not pass the vertical line test. And all linear functions, so linear functions being your mx plus b, those create slant lines. Okay, so not the horizontal line, we're not including it, but just the slant lines there. Okay, let's do something that I'm going to claim you know how to do. That's write an equation for the linear function f of x such that f of -1 equals 2 and f of 3 equals -2. You know how to do this very well if you figure out what they're asking. There's the catch. What are they asking us to do here? Write an equation for the linear function f of x. Okay, that right there is saying we're looking for y equals mx plus b. Okay, there's some remnants of y equals mx plus b in those heads, right? Your brains have learned y equals mx plus b. What about this f of -1 equals 2 and f of 3 equals -2? What information are they giving us there?
When x is equal to -1, y is equal to 2.
Right. So if -1 is an x value and 2 is a y value, they're giving me the ordered pair -1, comma 2. Okay. So, and then if f of 3 equals -2, they're giving me an xy combo again, aren't they? So they're giving me the ordered pair 3, comma -2. So if I have, and I'm going to bring it over here, the ordered pairs -1, 2, and 3, -2. How do we write the equation of the line? What do you need to do first?
y2 minus y1 over x2 minus x1.
Because she's finding the
And
slope, the m. This sounds familiar, right? So m is y2 minus y1 over x2 minus x1 is officially what you're taught. Basically, subtract the y's on top, then subtract the x's on bottom in the same order, right? And so you want to label these x1, y1, x2, y2, you can. -2 minus 2 over 3 minus -1. What are you getting? -4 over 4, which is -1. So we now know m, or our slope, is -1. Okay. I have m. What else do I need? B. What are my options for finding B?
plug in everything and solve it.
Okay, plug in everything you have and solve for B. We just found our slope, yes. Besides your slope, you're going to need an x and a y. Do we have an x and a y? We actually have 2 of them. Just pick one, right? So I'm going to pick the -1 too, only because I'm guessing that's what you guys will pick. And fill them in, right? So if it's y equals mx plus b, for y I'm going to use 2. M is -1 times x, which is -1, plus b. 2 equals -1 times -1 is 1 plus b. If it's 1 plus b, you're going to subtract 1, and b is 1. So what do you know?
Y equals -1 x plus 1.
Now, if I want to get nitpicky, they asked us to write the linear function f of x, so we could also list this as f of x equals -x plus 1, yes? In reality, am I going to get that nitpicky? Probably not. Considering I had most people on their inverse function just left it as y equals instead of changing it back to f inverse of x.
I did
So.
do that. That's not how I did.
So most people left it as y equals. Okay. Kind of some review there. Next topic is going to be average rate of change. So the slope of a linear function characterizes something called the function's rate of change. With a linear function, your rate of change is constant. So because a linear function, it's a straight line, it's always increasing or decreasing at the same rate. In other words, that slope is always the same value. It's going always up and over so many. Okay? Not all functions will have a constant rate of change. Okay? So all functions have rates of change based on different values of x. There's an average rate of change for a function given an interval. So the idea is if you have something that's just a line, it's going to be one set rate of change no matter where you look. If you have a curve, like for instance a parabola, whether you're looking on the decreasing or increasing side of the parabola will make a big difference in what your rate of change is. So that's why we'll talk about looking at an interval. Okay, so we're going to look at rate of change on the backside. The average rate of change of a function, y equals f of x, between x equals a to x equals b, where a cannot equal b, and that's just saying that your endpoints are not the same. You have to have an interval, is f of b minus f of a over b minus a. This is our formula for average rate of change. Now, what is that formula basically? It's written in a different form, but f of b minus f of a over b minus a.
Or y1 minus y2 over x2 minus x1.
Is this basically slope?
Yeah.
Yeah, this is basically a fancy way of saying slope. Okay, we just don't talk about it as slope for anything but a straight line. Okay, so these curves and stuff, we talk about average rate of change. So yeah, basically it's subtracting your y values on top, your x values on bottom. This was stated in the rule up here, the interval x equals a to x equals b. Realize the interval a to b can also be written in interval notation, a to b, and you'll see a little bit of both. Okay, so beware. So we have a couple examples of average rate of change. So compute the average rate of change for the following. So in order to do this, first of all, what are my a and b values? A and b are what?
-2 and 0.
Yeah, those are my -2 and 0. So, in all honesty, it's not really going to matter what you call A and what you call B, because when you subtract the pieces on top, it'll work out either way. I tend to go with the first number in the interval A, the second number B, but you wouldn't have to. Now, so those are A and B. We're also going to need to know f of A and f of B, which means f of A means I need to find f of -2. What's f of -2 going to be? Huh? No. F of -2 means I take my f function and I replace x with -2. So if my function is x squared, -2 squared, which is 4. We also need to know f of b. Well, my b value is 0. So I need to know f of 0. How do I do f of 0? 0 squared is 0. Okay, so right here, I know that f of -2 is equal to 4. And I know that f of 0 is equal to 0, right? So we're going to set this up. F of b minus f of a. Well, officially, if you want to f of b minus f of a, you can think of it as f of 0 minus f of -2. But didn't we already find those values?
Yes.
Yeah, what are those values? 0 minus 4. My denominator is just going to be b minus a. So 0 minus -2. 0 minus -2 is going to be +2. As in 0 minus negative.
But 0 is not.
Right. And minus a negative becomes plus a positive.
So 0 plus. Even if it's 0.
Uh-huh. Even if there's no number out there, it's minus a negative still becomes plus a positive.
Okay, I was not sure.
Yep. So 0 minus 4 is -4. Divided by 2 is -2. That's it. Okay, so this is f of x equals x squared. The average rate of change on the interval from -2 to 0 on that parabola is -2. Now, if you think about that, that's on the left side of the parabola. So it makes sense that I have a negative rate of change. Shall we try B? F of x equals 3x squared minus 1 on the interval from x equals -5 to x equals 3. What are my A and B values? -5 and 3. And set this up how you want. But I'm going to go ahead and find f of -5. So if I'm finding f of -5, I'm plugging -5 into the function, right? So -5 squared is 25 times 3, 75, minus 1.
Oh, there's a minus. Oh, I didn't see the minus one. Oh, yeah. I see the
I'm looking for 74.
Oh,
Okay, so yes, there's a minus 1. We have to square the -5 before we can multiply by 3. What other mistakes do I need to catch here?
I did 3 times -5 squared.
That's it, yeah. So the power is just on the x, square that, and then multiply by 3. Okay, let's see if this one goes better. F of 3. 3 times 3 squared minus 1.
26.
3 squared is 9, times 3 is 27, minus 1 is indeed 26. So we know that f of -5 is equal to 74. We found that f of 3 is equal to 26. Are we at least in agreement there? Okay. F of b minus f of a means I'm going to be doing f of 3 minus f of -5. Which means on the bottom it's going to be 3 minus -5. Let's see. F of 3 is 26 minus f of -5 minus 74 over 3 minus -5,
8.
8. 26 minus 74 is -48. Divided by 8 is -6. Okay. C.
We can just leave it here. That's good.
Okay. What are my A and B values?
That's a great question.
What are my A and B values?
AC.
A and C. So any place we would normally put an A in, we're going to put A in. Anytime we'd normally put a B in, we're going to think C, right? So we're going to use A and C as our A and B. Okay, so we're going to work with variables here, essentially. Now, okay, let's go for some basics here. If f of x is 16x cubed, what's f of a?
16 cubed. Or a cubed.
Just basically take the x and replace it with a, yes? We said some weird things out there, but you got the gist. It's 16a cubed. The other end of our interval is c. What's f of c? 16c cubed. Okay, so let's set this up. Normally we'd say f of b minus f of a. So we're going to say f of c minus f of a over c minus a, correct?
Mm-hmm.
So for us, that's going to be 16c cubed minus 16a cubed over c minus a. There's some cleanup and simplifying we can do here.
CA cubed.
What are the powers to h raised 0? Or 1?
Well, k Can't you clean up the top by doing 16 minus 16, which is 0, and then the C and the A would be C A?
No. Okay, so first of all, can I subtract these as is? No, they are not like terms. The first 16 is attached to C cubed, the other one's attached to A cubed. They're not like terms, so I can't subtract them. Okay? Now, and I'm trying to figure out what all I heard here. Can I cancel a C and an A? No. Because C minus A, you can't cancel one without the other. You'd have to cancel a factor of C minus A. However, there is some factoring we can do.
Oh, you can factor.
Okay? So, on top, what's the obvious piece on top?
16.
There is a GCF of 16. Let's start with that. So on top, I'm going to factor out a GCF of 16. When I factor out 16, I'm left with C cubed minus A cubed. All still over C minus A. Now, C cubed minus A cubed is what we call difference of cubes. We learned it in Algebra 2. Have we reviewed it yet this year or no?
I don't think so.
So it's calculus. I've reviewed it this year, but not Algebra 2 or not pre-calc. Okay. So the 16 is going to stay out front. C cubed minus A cubed factors into a binomial and a trinomial. Haven't reviewed this year then. Okay, fair enough. So, this is difference of cubes because it's subtraction. C cubed is a perfect cube and A cubed is a perfect cube. Okay? Now, cube root of the first term. What's cube root of C cubed?
C.
C. That goes in the first part of my first parenthesis. Middle sign stays the same, so it's going to be minus. What's the cube root of A cubed? A. So your binomial, your first parenthesis, is C minus A. Now, the trinomial. Yes. The trinomial. The first term of the trinomial, you take your first cube root and you square it. So our first cube root was C. What is that when you square it? C squared. Your next sign is the opposite of the original problem or the first parenthesis. So this is going to be a plus. For this middle term, we're going to multiply our two cube roots. Our cube roots were C and A. What is C times A? CA, or I'm going to write AC. And then your last term is your last cube root squared. So our other cube root was A. What is A when you square it? So it's going to, and that's always going to be a plus. So plus A squared. Okay. We did a little bit of that in Algebra 2. We're reviewing it now. We'll keep reviewing it some. My denominator was already C minus A. What coincidence just happened?
Take that.
C minus A cancels with C minus A. Your answer is 16 times C squared plus AC plus A squared. Now, if you start looking at homework, this is like, I want to say it's the very last homework problem. 82 is this. And 82, I don't know how many parts there are, probably like 8 to 10 parts.
What?
And it's doing this. But it's doing this each time.
But 8 to 10 times.
Yes.
So it's actually like 20.
Yes, there's more. 82, I don't know. Maybe I'm overestimating. Maybe I'm underestimating. I don't remember. 82
You're underestimating.
is a lot of this.
half of 82.
You're fine. Okay? So, just kind of an FYI. That's what 82 is. Instead of ABC, it's like A through K or something crazy.
Oh my God.
Okay?